Hello everybody and welcome to this reconstruction tutorial where I will show you the best process to build the soy sauce vessel with Shapr3D. While visually simple, this design has some very interesting geometry problems to solve. In this video I will show you how to set up effectively our sketches and use smart modeling techniques to build this design. Before we get started, let's make sure that our units are set to millimeters and all our grid and guide elements are turned on. This object I have put into a folder, including the two objects, and named it. We will use this as a reference to study how to create the sketches. Once the sketches are done, and then we will create our own solid geometry. Great! Now we can get started. So I mentioned at the intro that there are certain design problems that needs to be solved. And for example, if you take a look at the cap, we can see this is made out of two objects. The main revolve, the extrusion, we have some fillets. The top part is consistently arced. The sides are flat trimmed, but then the cap is actually, it's a revolved object. Also in the inside, we can see there is some space removed for the fluid outflow. So what is actually the best step-by-step here to do? And this is something we will take a look at. But first, let's start with the model. So we go to right view or side view, and we will begin everything with a sketch. At the center, 130 is fine. I do not want this point to move, so I will lock it. I will draw myself a line, 31 millimeters. And also here, I draw a line over, 14 millimeters. Go down by 11. And then I will continue here. Go over by 1. Can zoom in a little bit more by 3 and go back. And also here I give all those dimensions. Here I will dimension this edge. Very good. So at the bottom here we see there is an concave surface, this one. To create it, it's actually pretty easy. We need just an arc. So on the sketch here, we will create ourselves an arc with a nice arc motion. Then this point I will connect. And now this arc, I would like to be tangent to another line, which I drew here. The reason why I made a tangent is now I can simply drag this line down, and by this I modify my arc. See, this is a very easy and effective way to get the arc into the position I want. Very good. So let's now take a look at the model itself. How we do this? There are two types of curves we could use. The fit point or the control. In this case, I will use the control point. And we don't really know how many points we need. So from the bottom here, I will start, click, 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 leave it there, and then this point I move to there. Very good. So I have 1, 2, 3, 4, 5 points. Then I can go ahead and start moving these points. So as you can see, I'm massaging my curve to make it match actually the reference object. Since we were talking about amount of points for a spline, the big rule here simply is least amount of points is always the best because it's less work and it guarantees the most perfect curves. But sometimes you also need more points. So it's a matter of experimenting. What you do not want to do is try to do something like this. I overdo this on purpose because you make yourself life simply very difficult. Way too many points to create or trace this profile. it's a balance act. So always try to have the least amount of points with still trying to get the shape or flow you want. So at this point, I will show my cap because this spline I would like to flow into this edge here, which I'm tapping onto. So let's draw a line here. Zoom in a little bit, and this line we will connect. This I will make horizontal. Then I will bring this over. 1.5, very good. This I will bring to here. And this looks actually pretty good. Then an angle 104. 103.5. Yeah, this looks good. Very nice. You see, I cannot move any of these lines, and this all goes back to having everything constrained, and this start point here I locked. Very effective tool. So why did I draw actually this line? Check this out. So I'm drawing another line here. This line I will make tangent to this line. And then the spline I will make tangent. Sorry, I meant not tangent. This line is parallel to this line. And then this curve will be tangent to this line. Then this point actually I can only move tangentially to this line. And you see how I cannot go left and right anymore. So this curve now will flow kind of like, or it will stop flowing into the same direction this line actually looks. That's the reason why we did this. So let's take a look at the model. We now have to push and pull these points a little bit more. There we are. Yeah, this looks actually pretty good. This sketch we will rename Profile Front. There we are. Very good. And when we go into rotate, here this line actually we can bring back. Maybe we just do 2 millimeters. Why can we not do this? Let's take a look. What I want to do here is simply I want to bring this line down. Oh, there was a constraint added. A coincident constraint. So now I can make this too. So this stays actually inside this profile. So why did I actually draw the bottle and then the small element separately? Well, I should actually model each separately. Okay, so here's our main bottle. Here's my revolve axis. Revolve 360 degree. There we are. Very nice. Now we can turn this off. Before I shell it, I will fillet the bottom part, because now when I shell this by 2 millimeters, it then actually also fillets the inside correctly for me. So I don't have to calculate the correct or proper radius for this fillet, which is 3. This is 5. Material thickness is 2. So a fillet of 5 minus material thickness is inner fillet. Thanks to the amazing direct modeling capabilities of Shapr, I can select this bottom surface and offset it by 2 millimeters. So I'm adding more thickness to the glass. Now is actually the moment where I would add this to it. So there we are. And let's join them. I select it all. There we are. Very good. This is our bottle raw. And I can hide it for the moment. Now we can take a look at our cap. And how we will build this. This line here, first I will extend a little bit till there. I will extend a line here. And then from there to there I draw a line. This will be horizontal. This we make 12. I make this a little bit bigger on purpose. Very good. So this captures actually the revolve object. So this we will revolve around there. Very nice. Okay, so this part right now is done. Hide it. Show our cap. Turn this off. We go to the front view now. Because here we have actually a triangular object and then this inside part. Let's go step by step. Bigger problems very often are very easy when we break them down into smaller problems. This I bring over. Also here I make a line. Here comes a little modeling trick. See, this is actually at the center. This I will lock. So I will go to there and there. And now when I move this in, you see the other side moves. I use the grid snapping to simply bring everything into the position. When we zoom in more, we can snap even more precisely. I want to zoom in. There we are. Here, this I move down a little bit there. Now we have this perfectly lined up. Very good. Okay, so this element I will extrude down by 50 and then extend this to 100. Here's my original cap. You see the two objects nicely intersect. Select them all and we fuse them together. That's all done on purpose. Very good. Let's take a look from the side. We turn this off and show the cap, and we want to see our front profile. And actually this other sketch we will call profile side. And I will go to this side here since I have nothing there and just draw myself here this shape. Very good. Bring this a little bit more down. There we are. Okay. Very nice. So I'm using the grid trying to figure out, there we are, how this lines up. Cool. So this profile I can extend down by 40, then 80. And let's show our other object. There we are. Here we'll extend this over. It covers everything perfectly. Maybe here we extend this too. So I'm overbuilding. That's the term for it. There. And this one I need to be on the other side too. So I go to mirror, make a copy. So by keep originals. There we are. And then this, and this we do a subtract. This is actually my plus, this is my minus, this other one is my minus, we keep nothing, done, there we are. Cool. So now we have actually then trimmed, because they should look flat, while the cap is a revolved surface, but now we have to do the dome part. So how do we do this? I hope you start noticing actually how I broke the complexity of the cap down into very small individual elements. Let's go back to here. And I will, where do we put this in? Yeah, we will do this simply here. We'll add it to this part of the sketch. So a line we do here. Specify this, very good. We can also specify this so it doesn't move. Here again, we do an arc tangent to this line. And this I simply move to somewhere like here till this all lines up. Very nice. This point I could coincident constraint onto there. I simply leave it there so it's very easy now to move up and down. I prefer it this way. Because if I go into a 3D view, I have my profile here, which I can now revolve. And when this is not big enough or long enough, not a big deal. I simply direct model adjust it. It's also the reason why a lot of my sketches I always try to keep very simplistic, not too complex. Now, there we're actually going to have an issue. We see the surface I made does not intersect correctly. How do we fix this? This is actually easy. Here, this surface and this surface, I simply extend a little bit to there. And then I could go ahead and say, you subtract from this one. There we are. So now we have actually our nicely domed top, while the sides are cut flat and everything looks pretty good. If I want, let's call this first actually cap raw. This profile sketch I have here, this line could actually be a little bit higher. But you saw I didn't necessarily, or I don't have to go back and adjust the sketch because via direct modeling I was able to fix this. So I would try to see the sketches not necessarily what limits the geometry, but always gives you a base start. And then via direct modeling we finish it. Good. However, let's go back to the front view. So we have to create this hole. I will zoom in here and draw myself a line, and a line, and a line, and then an arc. The arc is automatically tangent constraint to each line. That's perfect. Then this goes up a millimeter. This goes over, and this goes over. And then these 2 points, I move up. There we are. And you see I use the grid for snapping and making sure everything is perfect. Very good. Now, with this selected, 50 and 100. Go to the cap. Now we can cut this out. Very good. And at this point, we select this interface, double tap. I draw myself a line here, then this line I will lock so the endpoints can't move. And this makes it very easy to put 2 arcs on it. Nice little trick, when you select 2 arcs, we can make them equal. And if I select 1 arc and then move it, okay. this case, actually, let's do it this way. So here we make this 90, and then this should be equal to there. Very good. Okay. So we were at a case where basically it made them equal, so it turned into a circle. But here now you see, by having this one ellipse defined, and the other ellipse simply use the equal command, I don't have to add a dimension to each ellipse. Very good. Now this profile I can select. I will stay in this view and start cutting into my object. There. Now it touches that surface perfectly, it lines up. This is also because I'm modeling again with the grid. Now keep in mind, here, this upper edge where I'm tapping onto, that was actually drawn on the grid. Also here, this surface, everything was going in grid steps. So when I extrude also, I can extrude in grid steps, which is why the extrusion stopped actually on the surface. Just a little trick. Very good. So let's go to the left view. Take a look what we have. We can call this opening. Let's sort everything a little bit. So my 3 sketches, I move into there. Very good. Hide this. And we are ready to make a copy of those. I move those up 200. And then the original ones here I can hide. Call this bottle finished. Call this cap finished. Because what we can do now is we start adding all the finishing details, fillets, and also the tolerance between these two elements. Everything is so perfectly modeled, it's too tight. We have no tolerance between the cap and the bottle. While actually, technically speaking, we could manufacture that way, it just would make this a very expensive product. Cool. Let's take a look at the bottle first. It's actually pretty easy. Here we say 0.25. We can do the same for those edges. We simply round them a little bit. This is a sharp inner edge, which we can round if we want to. But it's actually not able to move that much. There you can see where it is. So maybe 8. So based on how far the geometry allows us to add the fillet to it. And the rest is pretty much done. Very good. Then let's take a look at the cap. And I will go to the inside here first. Here, there, and there. We added those to be 0.25. If we want to, we can round this to a little bit bigger, 1 millimeter, and then we can round those 1 millimeter. Maybe help the fluid to flow a little bit if necessary. The rest of these edges we really can keep where they are. We don't really have to round them. This is not something we would really touch or so. But the really interesting part now is how do we round the outside here? So, and similar to the way how we modeled this cap, also filleting multiple edges that connect, there's a particular step-by-step. So if I fillet this first, I can fillet this, and my end result is this. Now take a look what happens when I actually fillet this first by 1, and then I fillet this by 2. You can see it's a different look. It's a nicer look. So I have to round actually some edges. Here again, 1 and 2. And again, because we are in direct modeling, we can adjust all the fillets later afterwards, which is pretty cool. Now, because I have here very nice rounded edges, I can select both and then fillet this 0.5 millimeter, and then this edge and this edge we will round. Oh, we have to be careful how, as we move this, we will round this by 0.25. I zoom in a little bit, so you see this is 0.25, this is 0.5, and I have right here where I'm tapping a very nice rounded edge. So be careful or mindful of the edges and the radius you use for each. Very good. So the fillets are done. I always do fillets at the end because they are more or less just a finishing feature. They're not necessarily a design feature, and that can be very time consuming, so do them at the end. The last thing is our surface tolerance. There are multiple ways how we can add tolerance. I can select a surface. This is 7 millimeter. Okay, we want to have 0.1 millimeter offset, so 6.9. And you see, there's a tiny gap. Inside the bottle. Here we do the same, 13.9. Oh, this is actually 14.1. We shrank it, we have to grow it. There we are. We can, however, also simply select a surface, go to move, and then move it by 0.1. There we are. Okay. So normally there's also a threading in between this surface and the glass rim. There is also a silicone seal. This is then basically how the title lock is created. To finish this design, we can give this some nice colors. Make this maybe a good red, and then this, maybe a brown. We can give this a transparency if we want to simulate that there's some sort of fluid or this is a glass body. Yeah, and that basically sums up the process how to model this soy sauce vessel with minimal sketches and an optimal use of direct modeling tools in Shapr3D.